Hello all. So in the last session we were talking about the different libraries that we use for working on with machine learning algorithms. Today in this session I would like to discuss about two tools that we use for working with machine learning algorithms. Okay. So in order to develop your machine learning models we'll be using Jupyter Notebook or Google Colab. You can use either of them and you can develop your machine learning models. Okay, so when we talk about Jupyter Notebook, all of you must have worked on Jupyter Notebook for when you've worked with Python programming. Okay, so Jupyter Notebook is a simple open source web application that will allows us to create different IPNB files, that is Python notebooks. You can share these documents, you can perform various visualizations, you have code cell, you have text cell in that. Okay, so this is basically widely used in data science, machine learning, academic research because of the versatility in use. Uh, I would like to discuss about important features of Jupyter Notebook. As you all of us know, Jupyter Notebook has interactive code execution. You can write and run the code in various programming languages such as Python and R. Most probably we are using Python for machine learning programming. Okay, so you also have leverage to use different libraries like NumPy, Pandas, Matplotlib, TensorFlow, PyTorch, etc. And then you have code cells which allows us to run code interactively with the output displayed directly below the cell in Jupyter environment. When we talk about rich text, you can also use Markdown to write narrative text regarding each and every block of code that you write. Okay, basically this is used for documenting your code and explaining the concepts that you have written in the coding part. Okay, so using Jupyter you can also do data visualization, for which you have different libraries which are available like Matplotlib, Seaborn and Plotly. You can create graphs and have interactive visualizations within the notebook using different libraries. Okay, so these are some important features of Jupyter Notebook. And when we talk about installation, you can directly install Jupyter via Anaconda, and you can run the Jupyter Notebook from the terminal with the command Jupyter Notebook by just typing the command Jupyter Notebook. Okay, so the browser will open with the Jupyter interface where you can start creating and working on with your notebooks, where you can create your IPNB files. Okay, so uh, when we talk about cells, the cells are the building blocks of the notebook. So you have code cell, you have text cell. Okay, so the kernel executes the code which is there in the notebook. You can also start the kernel, stop the kernel, or restart the kernel as when required. Okay, so this is all about Jupyter. Next, when I talk about Google Colab, Google Colab is short form for collaboratory. Okay, so this is a free cloud-based service provided by Google that will allow the programmers to write and execute the Python code in web-based environment. This is particularly most important and widely used among data scientists and machine learning engineers because it provides access to the powerful computing resources including GPUs and TPUs. Okay, so as when you go for deep learning models or an advanced transformer based models, or when you work on with generative AI, we need GPU, TPU processing or GPU processing other than CPU, for which we use Google Colab. Okay, so talking about the important features of Google Colab, Google Colab is a free cloud resource. Okay, so basically the main important feature is it provides access to use GPUs and TPUs which are used for running heavy computations like deep learning models or other intensive tasks. And no setup is required. As this is cloud based, you need not install any software or anything locally. You just need a Google account to get started with working on Google Colab. As Google Colab has integration with Google Drive, it can allow you to save your notebooks and access your notebooks which are already built directly into the from the drive. Okay, so file sharing, Google Docs, real-time collaboration is also available with respect to Google Colab. Similar to Jupyter Notebook, this also has rich text and visualization. Google Colab also supports libraries like Matplotlib, Seaborn, and other visualization libraries. Okay, so there are many pre-installed libraries which are available inside Google Colab. NumPy, Pandas, Sklearn, TensorFlow, Keras, PyTorch are already pre-installed. If you want something else apart from this also, you can install by using pip command. Okay, so when you want to work on Google Colab, you just have to go to Google Colab and sign in with your Google account and start working on your notebooks. Okay, so in runtime you have this option of changing the runtime to GPU and work with GPU processor for advanced applications. You can also access Google Drive, and already almost all the packages are pre-installed, but if still you want to install additional Python packages, you can still install by using pip install command. Okay, so this is all about Google Colab. Okay, now let's start working on experiment 1. Okay, so I'll show you, before we start with experiment 1, I'll show you how do we work with Google Colab. So just go to Google and type Google Colab. Okay, so when you just type Google Colab, you'll be diverted to the environment where you can access all the files. Okay, now as you can see, we have this option. So here just say new notebook. So when you click on new notebook, you'll be directed to the path where you can access the new notebook. If you don't want to use this new notebook, if you already have IPNB file, you can just say file upload notebook. Okay, you can upload it from your GitHub, you can upload it from Google Drive, you can upload it from, you can browse, and you can upload the files. Okay, now I have this file, so let me upload this file here. Okay, so in this way you can either create a new file or you can directly go from the existing file. I mean, you can create a new file or you can upload the existing file. If you already have your file in the folders, you can directly upload that. Okay, so as you can see here, we have code cell, text cell. Suppose I want to write something, just click on this text cell. Okay, so the text cell would be available. Okay, so on top of this code cell also you have this option. You can directly click on that such that codes text cell will appear. Okay, you can just type experiment 1. Okay, linear search algorithm. Okay, so in this way text would be displayed. Okay, this is the text cell and this is the code cell. So in this way you can work on Google Colab. Okay, now when you want to run this particular cell directly, you can click on this. Okay, so when you click on this particular button, the running process takes place. Here it says connecting to Python 3 Google compute engine backend, wherein the code will be run. Okay, so for working on with Google Colab, you need internet. Okay, this is connected to your email. Okay, so in this way we can run, and then if you want to change the runtime, just go to runtime and say change runtime type. You can see initially it will be CPU. You can switch on to TPU also. Okay, so this is how we work on with Google Colab. Okay, now all of you know about Jupyter, right? So you can just go to the Jupyter environment and say new file. Okay, you can create a new notebook. Okay, so once you create a new notebook, you can start working on with the experiment. Okay, so let's start doing experiment 1. So let's say experiment 1 is on experiment 1 is on linear search problem. Okay, so as discussed in the previous sessions, AI works with if then rules. Like when you want to execute something or perform some task, you have to go with the rules, right? So we will perform some linear search problem on array using the basic AI method. Okay, now when I type this, if I want to make this into text cell, what I do is I just go to code and say markdown. Okay, so when I give a markdown cell, that would be taken as a code cell. Okay, just give an hash symbol and then say markdown. Okay, so that will be a text cell. Now let's start working on with the linear search algorithm. So first I define a function called, let's say, linear underscore search. Okay, I'm defining a function called linear underscore search with two parameters given into it. One is an array and the second one is target. Okay, I've created a simple function. Now I say for index comma value. Okay, I want to create an array and find the position of that particular number in the array by using linear search method. Okay, and then I say in enumerate, I say array. Okay, and then I say if value, if I suppose I want to search for a value, if that is found, let's say that is equal to target, I say return index. Otherwise I say return -1. Okay, so here I am performing a linear search for finding the target value. Okay, so if I don't find the target value, I'll return -1. Okay, so this is my code. Now I'll run this. Just go with shift enter. Okay, now I have run this block of code. Now let's use this. Let me create an array. Let me create an array with some random elements. Let's say 10, 23, 4, 6, 35, 72. Okay, I've created an array with random elements, and then I say target is equal to 35. Okay, now what did I do? I am just, as you can see here in the Google Colab environment, let's try to explain you this. Okay, I just want to check if my number is present in the array or not. Okay, so I want to implement some binary search algorithm. Okay, so here I've taken an array with the target value. Now I just want to check if this target value is present or not. Now I say result is equal to, I want to type my result, which says use the binary search algorithm. Okay, or linear search algorithm that we have declared. So linear, use the linear search algorithm. Target, use the linear search algorithm with y values. Okay, now I have taken array, comma, I have taken target. Okay, now I say if is not equal to -1. Okay, if the result is not equal to -1, I say print, I say print target found at index. I want to type my index if the result is not equal to 1. Okay, so I say result. Okay, or else I say print target not found in the array. This is the simple message that I want to display. Okay, let's run this. Okay, so as you can see, it says my target value is 35 and it is found in the index 4. So I have 10, 23, 4, 6, 35, 72, 78 as numbers. 35 is available in index 4. This is 0th index, first index 23 value, second index 4 value, third index 6th value, fourth index is 35. Okay, so this is how we simply apply linear search for finding out the index in a number. Okay, this is all about experiment 1. Thank you.